Okay, welcome back. So we're moving on to activity 5 of module 3, topic 3, lesson 1. This one is beginning on page 472. Some finished this in class today, this page at least. Others did not. No one finished page 473. So if you are watching this in class and you already did this, then you can just listen to it until we get to the part where your class needs to pick up on the rest of the lesson. So it says the question matters. So we learned about the total cost and the profit. It depended on how we were looking at it, how we were asking the question on which one was the independent and which one was the dependent variable. So initially, so it says the situations in the previous activities are similar but presented in two different ways. So initially we had the profit depends on the total cost. So the whole cost of the items, the total cost of all the items times the 20% gave us the profit. So we said our profit was 20% or 0.2 as a decimal times the total cost. Again, you can put that 0 there, you don't have to. And then we turned it around a bit and we said, well, what if we know what we want as a dollar amount for profit and we know we want 20%? How do we figure out the total cost? So the total cost, it's really of the items, depends on the profit we're seeking. And then we used our algebraic one-step equation method and we solved for t, getting a total for the cost of the profit divided by the 20%. So it says, what do you notice about the two equations? Well, they both have t's, they both have p's, and they both have the 0.2 or the 20%. So they're the same, but they're solved for different variables. And they use inverse operations. So where the first one used multiplication, the inverse of multiplication is division. This one uses division. So it says, how does examining this same situation from different perspectives affect the independent and dependent variables? Well, really, what did we do with the independent and dependent? Yeah, we just switched them. So we can say and we're just going to say I for independent and D for dependent variables are reversed and what did that do? Which changes the way we wrote the equations. Again, you can pause this anytime you need so that you can get something written. I'm going to keep writing. I'm going to see which way is better here with the lights on or off. Okay. Says, what can you conclude about the designation of a variable as independent or dependent? What do you think? I want you to think about it for a second. What can you conclude? What conclusion can you come to about whether we assign a variable as independent or dependent? In each of these, it depended on the situation, right? It depended on what we were wanting to find, what we knew, what part we needed to find. So we can say whether a variable is independent as I or dependent which is a D. Oh my gosh, I'm so sorry. Is determined by the scenario or situation and the question being asked. Okay, if you need to pause to copy that, please do so. I'm going to continue. Okay, so I think only one class got to this part. It said compare the two graphs in the last two activities. How are they similar and how are they different? So how were they similar? How were they similar? They both showed a relationship between what? What were the two things? Total cost and profit. How were they different? And again, we're talking about the two graphs. So the labels were reversed depending on how we defined the independent and dependent variables. What do you notice about the independent and dependent variables? So when we go back and look at those graphs, and we've said this a couple of times, the x-axis is always the independent variable. The y-axis is always the dependent. Okay, it says consider another scenario. Dawson purchased a diesel-powered car that averages 41 miles per gallon. This kind of makes me smile because my son's name is Dawson. I took a picture of this question and sent it to him and said it finally happened because he never sees his name on anything, no keychains or Christmas ornaments, or when he was a little kid, the little license plates for your bike. He never had any of that, so he was very excited. Anyway, suppose Dawson is interested in how far the car travels on a given amount of gas, knowing he purchased a diesel-powered car that averages 41 miles per gallon, but he wants to know how far can it travel on a certain amount of gas. So based on this, what's the independent and what's the dependent? How does this phrase help us determine that? So he's wondering how far the car travels given this. So he's saying the independent is going to be the amount of gas. AMT is amount, abbreviation, amount of gas. And he's wondering the question, what he's trying to figure out, the dependent variable, is the number of miles traveled. Okay, so then it says define variables for each quantity and identify which is the independent variable and which is the dependent. Well, we just did that really, so I'm just going to continue to draw an arrow here for the amount of gas. Why don't we use G for gallons of gas? And for our dependent, M seems logical, for miles traveled. I'm just going to put a D under here and an I here so it stands out to me. Then it says write an equation to represent the relationship between the two. So we know that he gets 41 miles for every gallon. So he knows the amount of gas. He's trying to figure out how many miles. So 1 gallon of gas will get him what? 41 miles. What would 2 gallons of gas? So 1 gallon is 41 miles. 2 gallons is 82 miles. 3 gallons would be 123 miles. Is there a faster way for us to do that? Yeah. So 41 miles for every gallon. So 41 times the number of gallons of gas. So 41 times G will tell us how many miles he can expect to go. This is good. I had a car once that the gas gauge didn't work, and I needed to know that. I knew about how many miles I got for each gallon, and I just had to set my trip mileage indicator so I knew when I needed to go get gas. Okay, turning the page. So it says, suppose instead that Dawson runs out of gas on a regular basis. He's interested in how many miles of gas he has used when he knows how many miles he has driven. So this is kind of what I would have to do. It says identify which variables represents the independent quantity and which variable represents the dependent. So this time says he's wondering how many gallons of gas has he used when he knows the number of miles. The part he knows is the independent. He knows this. So depending on what that is, will give him the answer for the gallons of gas. So our equation the last time was miles equals 41 times the number of gallons. So if he's wondering how many gallons, if we can solve for G, we should have our new equation. So if we divide by 41, because 41 G means 41 times G, inverse of multiplication is division. So divide by 41 on both sides of the equal sign. So that cancels out. We're left with the G equals the number of miles divided by 41. I'm sorry, that goes down here. Identify which variable represents the independent quantity. Kind of got ahead of myself there. So the independent, we said here was the miles, so independent is M. And the dependent is the gallons of gas. My apologies. We kind of labeled it up here, but get it all written out there for you. So go ahead and get that written down. So next it says, how would you expect the graphs of the two situations to be similar and how would they be different? So it'd be very much like our last question with the profit and the total cost. On one graph, we would have what? Let me just kind of probably be faster if we just did this. We would have miles on the bottom and gallons of gas on the side. So this is our independent. This is our dependent. So that's this one that we have right here. On the other graph, it was reversed. The gallons of gas was the independent and the miles was the dependent. So this is the X, this is the Y. So on one graph, it would look like this. On the other, it'd be this. This one was the one from number 6. This graph is the one from the one right here above number 7. This one is right here. Okay, additional information that we should include here. How would you expect the graphs to be similar and how would you expect them to be different? So here's how they're different. They're going to switch. The dependent is always on the vertical axis, also known as the y-axis. They also both showed unit rates, which means it shows equivalent. That's a terrible cube. Let's redo that. Equivalent ratios. Talked about equivalent ratios several units ago, a couple modules ago. And they both would form straight lines. Would they be continuous or discrete? No, they would be continuous. Okay. The talk. We're actually going to stop here. We'll pause this and we will come back